Hello, welcome to Train Signal. You're watching this lesson on the thin provisioning feature in vSphere. In this lesson, you'll be learning what thin provisioning is and how it can greatly reduce the amount of disk space that your VMs take up on your data stores. We'll be covering how thin disks differ from traditional thick disks and how you can use the storage vMotion feature to convert disk types. Finally, we'll cover some tips and best practices for using thin disks, including how to properly monitor and manage them. Thin provision disks are virtual disks that start out small and grow as data is written to them. Unlike thick disks, where all space is allocated at the time of disk creation, when a thin disk is created, its initial size is 1 megabyte, or up to 8 megabyte depending on the default block size of your data stores. After their creation, a thin disk grows up to the maximum size that was defined when it was created, as data is written to it by the guest OS. So if you created a VM with a 20 gigabyte disk using the thick format, it would take up 20 gigabytes of disk space on the data store as soon as it was created. If you did this using a thin disk, it would start out at 1 megabyte and then grow as disk blocks are written to it during the operating system install and subsequent writes to the disk. Thin disks allow you to over-allocate disk space to virtual machines so the maximum sizes of the VM's disks exceed the size of the data store that the VMs are located on. This is similar to the way you can over-allocate memory to VMs so they can exceed the amount of physical memory that a host has. However, unlike memory, which can be swapped to disk when a host's memory reaches capacity, with thin disks, if they grow and not enough disk space is available on the data store, it will cause the VMs to shut down. As a result, when using thin disks, you must closely monitor their growth to ensure that they have sufficient disk space for them to grow. Thin disks existed in VI3, but their use was limited because they could only be created using the VMK-FS-Tools command line utility, and there was no reporting or monitoring tools to keep track of their growth. When thin disks grow, disk blocks are allocated and zeroed on demand in increments equal to the default block size of the data store. As a result, thin disks have a slight performance penalty both as they grow and space is allocated on demand, and also when the first write to a disk block is zeroed on demand. Once the disk has grown and its blocks have been zeroed, they have the same performance as the other disk types. Thin disks will not shrink on their own as data is deleted from them, because once a disk block is written to, it contains data even if it is from deleted files. The virtualization layer is not aware of what the operating system is doing to the disk, and it only knows that the block was written to once. It is possible to reshrink a thin disk, though, using a utility run inside the operating system that zeroes the deleted disk blocks so they no longer contain any data. An example of this utility is the Windows sdelete utility, also known as secure delete. Once the disk blocks are zeroed again, you can use storage vMotion to reshrink the disk while the VM is running. If you are not licensed to use the storage vMotion feature, you can also use the VMK-FS-Tools utility to reshrink a disk, but it requires a few extra steps and also that the VM be shut down. VMK-FS-Tools is an ESX service console command that is also available in the vSphere command line interface and is a general purpose disk utility that can do many disk functions, including conversions. You can view the actual size of a thin disk in a number of areas in the vSphere client. On the Virtual Machines tab, on the Summary tab of the VM, in the Data Store browser, or in the Special Storage view. The maximum size of a thin disk is referred to as the provision space, and the current size of a thin disk is referred to as the use space. Now, let's look at a demonstration of viewing thin disk sizes inside the vSphere client. Okay, we're now going to look at various ways of looking at disk sizes inside the vSphere client. Here's the first method using the Virtual Machines tab. So we're going to click on our cluster so we see all the virtual machines in the cluster, and then click on Virtual Machines. Now you'll see two columns for disk space, provision space and use space. Now you really need to understand what these columns mean. Okay, this disk here, we'll take this server, this VM called Amethyst as an example. This VM has a 20 gigabyte thin disk. So you might be wondering why the provision space shows 24 gigabytes. Well, the reason for that is The provision space shows the total amount of space that a VM could potentially take up. It's not actually the amount of space it's currently taken up, but it can potentially take up to 24 gigabytes of space. Now, that virtual disk is only 20 gig. You might be wondering where the extra 4 gigabytes is coming from. Well, this VM has 4 gigabytes of memory assigned to it. So when the VM is powered on, it creates a 4 gigabyte virtual swap file on the disk of the data store that it's located on. So that totals up to 24 gigabytes of provision space. Now, if you look over here at use space, it shows 5.69 gigabytes. Now again, that's kind of a little bit misleading because currently the size of the thin disk is about 1.69 gigabytes. The reason it shows 5.69 gigabytes is it also accounts for the virtual swap file that is 4 gigabytes in size. So the total space in use by this VM right now is 5.69 gigabytes. Now if we powered this VM off, that would change because the virtual swap file is deleted when the VM is powered off. So once we power this VM off, the use space would go back down to 1.69 gigabytes. The provision space would stay at 24 gigabytes because, again, that's really not the actual space being used by the VM. It's the amount of space it can potentially take up, which when powered on and when the disk is full would be 24 gigabytes because of the 20 gig disk file and the 4 gigabytes in the virtual swap file. Okay, the next method of looking at the virtual machine disk sizes is looking at the virtual machine summary tab. For that, we'll select the virtual machine on the left. All the information about the virtual machine displays. And over here you can see the provision storage, not shared storage, and used storage. Now the provision storage is showing as 24 gigabytes. And now the reason for that, like we explained before, is that the VM has a 20 gigabyte thin disk, but the VM can potentially take up 24 gigs total disk space because once that thin disk grows all the way to its maximum capacity, it would be 20 gig plus the 4 gigabytes that is in use by the virtual swap file on the VM. Not shared storage is basically the same as used storage because this VM does not share a disk with another VM, so the used storage and the shared storage are the same. The used storage, again, is this VM is using 1.69 gigabytes of disk space for its thin disk, and then the additional 4 gig comes from the virtual swap file that is created. If this VM was powered off, then you would see that drop down to 1.69 gigabytes. Select another VM. Now here's a VM that has a thick disk. It's not thin. This VM is powered off, and it has a 24 gigabytes disk, a thick disk, that because it's a thick disk, it's taking up the full 24 gigabytes of disk space on the data store right now. And it's shown as 25 gigabytes for provision storage because this VM has 1 gigabyte of memory assigned to it. So when the VM gets powered on, a 1 gigabyte virtual swap file will be created on the data store, resulting in a total of 25 gigabytes of total disk space and used by this VM. The next method we're going to look at for looking at virtual disk sizes is through the data store browser. So to use that, we'll basically select a host. It'll list the data stores that host can see. So we select that data store, right click on it, and click Browse Data Store. This launches the data store browser where you can see all the directories for the virtual machines that are located on that data store. So now we're going to select a VM. And here's all the files in that VM's home directory. Now this VM has a thin disk, and you can see now that this is the actual current capacity, the current size of this thin disk. It's about 1.8 gigabytes. You can also see the vswap file that's created when this VM is powered on. This file will go away once the VM is powered off. It's created on the fly once the VM is powered on, and it's used for hosts that have memory that's overcommitted. So in case the host runs out of physical memory, it starts using this vswap file for virtual memory for that VM. And here's the other files that make up the VM. You can see the .vmx file, which is a configuration file, which is really small. The vmxf file is another configuration file, again small. VMSD file is used for snapshot data, and there are none, so it's basically 0 bytes right now. The NVRAM file, another small file. This is used for the virtual machine BIOS. Then some log files that are created on the VM, and again, those are very small also. If we select another VM here, this one actually has a 10 gigabyte thick disk. So you see the virtual disk size is 10 gigabytes because all that space is allocated once that VM is created because of the thick disk. Now you won't see a vswap file here because this VM is powered off, so it doesn't have a vswap file. Those are only created when the VM is powered on. And then again, you see all the other supplemental files that this VM has on it. Okay, let's take a look at the final method for looking at virtual disk information, and it's probably the best method. It's a view called the storage view. It's only included in vCenter server. If you connect to an ESX host directly, you will not see this view. It's available on every object, so if you select a host, a VM, a cluster, data center, you'll see that. We want to select the cluster so we can see all the VMs in that cluster. And now we just scroll over here, select the storage view. And here's all, this is basically showing a lot of information all in one spot. So by default, it doesn't show all these columns. You'll see there's a lot of columns here. You need to enable them. So to do that, you right click, you select view column, and I've already selected these columns, but a lot of them by default are not selected, so you have to go in there and actually select them. So once you get all the columns showing, we'll kind of explain what each column means here now. Provision space is the total amount of space that the VM could potentially take up. It's not the amount of space that the VM is currently taking up, but it's the amount of space it could potentially take up based on all of its all the files that will get created for that VM, the maximum space that those files would take up. If you look here, this one says 24 gigabytes, and that's a total of the 20 gigabytes that the thin disk could potentially grow up to, and then 4 gigabytes of the virtual machine swap file that gets created when that VM is powered on. If you look down here, here's one that's 11 gig, 10 gig from the virtual disk, and has a 1 gig virtual swap file that will be created when the VM is powered on. This also includes snapshots. So here you see a VM with a 15 gig virtual disk. The provision space is showing double because that snapshot, when you create a snapshot, a second virtual disk is created where all the disk writes happen. The original disk is only read-only. And all the writes go to that second virtual disk, which can grow up to the maximum size of the original virtual disk if all the disk blocks are written to. So that's why the provision space is 30 gig. Once that snapshot is deleted, that'll go back down and we'll be back at 15 gig because that second virtual disk will get merged back into the original virtual disk, and there will only be one virtual disk. The virtual disk space column shows the total space used by the virtual disk files of that VM. And here you can see 1.69 gigabytes of disk space, and that file is a thin disk, so it's basically growing. It's a small file right now, but will grow over time. Here you can see one that's 24 gigabytes. That's the thick disk, and that VM is all the space is allocated at once, so it's currently 24 gigabytes. Here you can see a smaller one that's only 473 bytes. It's basically a new VM that was created that nothing's been written to the virtual disk file yet. It's a thin disk, and again, that will grow over time. Some more columns. You have the uncommitted space, and that's a space that hasn't been written to yet by the VM, but it could potentially be written to. So this VM has a 20 gigabyte thin disk. So 1.69 gigabytes of that is currently written to, but 18.31 gigabytes are remaining of that thin disk that haven't been written to yet. So that thin disk is basically could grow up to 20 gigs, so that the remaining 18.31 gigabytes of space could be used. You'll see a bunch here that have a 1 gigabyte of uncommitted space, and that's because the VM is powered off right now. But when it gets powered on, it's going to create a vswap file equal to the amount of space, the amount of RAM that's assigned to that VM. So you can see here 1 gigabyte of space will be used when that VM is powered on. It's currently uncommitted, but once the VM is powered on, it's going to take up that space. Same situation here where 4 gigabytes of uncommitted space exists because the VM is powered off. It has 4 gigabytes of memory assigned to it, so a 4 gigabyte virtual swap file will get created once that VM is powered on. The space use column is the total amount of space that a VM is currently taking up, and that's with all of its files. So that includes a total of the virtual disk files, any snapshots running, all the little files that are part of the VM, the log files and the NVRAM files and all that. This is the total amount of space that VM is taking up. So if we look here, here's a new VM that's really, there's just a few little files there because the VM hasn't been powered on yet. Nothing big there. Some other ones, these are mostly thick disks. There's a lot of space in use because the disk is thick, and all the way up to, here's our biggest one. So this view here, you can sort each of these columns, and this is a great view for kind of seeing what's taking up the most space, which, your VMs, which one is, you can kind of keep an eye on them, to see how large they're growing and which ones are taking up, the most room and the least room. Next is snapshot space. And this is the total space used by snapshots. You can see that one VM has basically a very little snapshot right now. And this is a great way here to keep track of your snapshots all in one view. So if you go into this view and sort it, it's a good way. All the VMs with snapshots will be up at the top because they'll have numbers for it won't be 0 bytes. 0 bytes basically means that the VM does not have a snapshot. So this is a great way of tracking which of your VMs have snapshots, so you can kind of, a lot of them you may want to delete, so you can see which ones have it, so you can go and delete them. The swap space is the amount of disk space that the virtual swap file of the VM is currently taking up. So you can see here this VM is powered on, and it currently has a 4 GB swap file, because there is 4 GB of memory assigned to that VM. This one again has a 1 GB swap file because there is 1 GB memory assigned to that VM. The rest of the VMs are powered off, so you don't see the swap files. If you have a VM that has a memory reservation, that is taken into account for the virtual swap file. So if you have a VM that has a 4 GB of memory assigned to it, normally without any memory reservations, a 4 GB virtual swap file will be created when the VM is powered on. Now if you set a memory reservation for 3 GB, what happens then is only the remaining space is used for virtual swap files. So because 3 gigs of memory is reserved for that VM, there's no potential of swapping that to disk, so only a 1 GB virtual swap file would be created to that VM. If you had a VM with 4 GB of memory and a 4 GB memory reservation, then there wouldn't be any swap file created for that VM because it's got 4 GB reserved to it and it would never swap. Swap files are deleted automatically once you power a VM off. So if we powered this VM off here, that would go away. That 4 gig virtual disk file, virtual swap file would be deleted, and it would be recreated again once the VM was powered on again. The other VM space is all the other little files, and it shows you here exactly what those files are. Configuration files, suspend data, NVRAM, the log files, all those files that aren't included in the other columns, the virtual disks and snapshots and swap files are added up here. These files are usually pretty small. None of them really grow that much, so this is just kind of a good way to keep an eye on the other files that are in use by that VM. If you see a VM with a large amount, it may have a lot of log files that you can go in and clean up. So again, sorting this column by size here gives you a good example of which VMs are taking up the most space, so you can maybe go in and investigate that. And then the last column here is the shared space, which is only for VMs that share virtual disk files, which we don't have any VMs here that do that. And well, there is one more column here, but it just shows you the number of virtual disks that VM has. So this storage view is a great way for seeing all your disk information all in one spot. And you can find out, you can sort each column, and you can see exactly what's going on with disk space in your environment. So you can, take care of things if needed. You can see how big your thin disks are, how big your swap files are, how big your snapshots are, and just everything, all the files combined. You can see it all in this one view. So one last thing is you'll notice the update button here. This view is not real time; it updates periodically. So if you click the update button, it'll go through and kind of just update all the columns and bring everything up to date. So Storage View is a great view, and I recommend that you use it because it can show you a lot of great information all in one spot. There are really no requirements for using thin disks. They work with any type of data store storage, including local disks, and iSCSI, NFS, and Fiber Channel shared data stores. Thin provisioning is not a licensed feature and is available in all editions of vSphere, including the free ESXi version. As far as limitations, you cannot use the fault tolerance feature with thin disks. When you enable fault tolerance on a VM with a thin disk, it will automatically be converted to a thick disk. A concern with thin disks is the performance impact of the operation that occurs when they grow, as well as the increased fragmentation that may occur. Thick disks are written all at once, so they're usually written on contiguous disk blocks. Thin disks, though, are written on demand and can be scattered across the physical disk. VMware, however, has done performance studies that show that the impact of this on thin disks is very negligible and should not discourage anyone from using thin disks. Okay, let's take a look at how to use thin disks. To use thin disks on a new VM, you create the VM as usual. When you get to the Create a Disk screen, you select the option to allocate and commit space on demand. Let's look at a demonstration of creating a new VM with a thin disk. Okay, here we're going to create a new VM and specify that a thin disk be used instead of a thick disk. So we select our host, select New Virtual Machine. You can use the typical configuration wizard type. You don't have to use a custom for this. We'll give our VM a name. Next, you select the data store for the store of the virtual machine files. We're just going to select this default one here. Select an operating system. Select any one you want. Here's where we're actually creating the virtual disk. So it'll default to a certain disk size. You can change that to whatever you want. And this is the important one here. You want to check mark the allocate and commit space on demand, thin provisioning. Now if you don't check that, it's going to create a thick disk. So check that, and then once you click next, finish, that virtual machine is created with the thin disk. So that disk is going to be really small, and it's going to grow up to that 12 gig total capacity over time as data is written to it. You can convert existing thick disks to thin disk using storage view motion while the VM is powered on. However, there is a catch to this. You must move the VM from one data store to another. If you select the same data store, the disk will not be converted. You can move the VM back to its original data store afterwards, though. If you only have one data store, then you must power off the VM and convert the disk using the VMK FS Tools utility. Let's now look at a demonstration of converting a thick disk to a thin disk using storage vMotion. Okay, here we're going to demonstrate how to convert a thick disk on a VM to a thin disk using storage vMotion. Now there is a catch to this, that you have to move the VM to another data store to convert it. Now we'll show you what happens if you keep it on the same data store. Select the VM, select Migrate, select Change Data Store, which does the storage vMotion, select Next. Now the VM is currently on this gold-local data store. If we leave it there and say Next, say Thin Format, and click Next, and click Finish, it completes right away. If we go back and look at the VM, edit its settings, select its hard disk, you'll see it's still the thick format. So that didn't actually do anything, it just kind of left it in the same spot and did not change the format. So